In this chapter, we'll be looking at how to solve a problem that we've actually created and using the inverse foot rig. At the moment, the foot appears to work perfectly well. We can lift it and the knee bends. However, as we pull the control further and further away from the leg, the ankle starts to become separated. This would just rip our mesh. Same as if the character moves from the waist up. He can step away and actually leave his feet completely behind. It would be best if we could actually set it up so this leg always tried to keep the distance and stretched out to point at the ankle. We still have yet to actually connect the leg to the spine, so let's do that now for testing purposes. I'm going to pick the nub bone, or that extra little bone we created at the top of the thigh, and I want to link that to the nub bone on the base of the spine. Now when we wiggle the spine, the top of the leg should go. Stretchy bones are actually built into Macs as a default. I'm going to open the Bone Tools dialog, and I'm going to turn off the freeze length on this bone so I can do this manually on screen. Now that I've turned off freeze length on the calf bone, you can see that when I pull the nub bone at the end, I can actually stretch out the calf bone. The nub bone isn't moving down because there's an IK solver on it holding it in this place. And I won't allow it to get it any longer. I can actually make it shorter though. The other nice thing is you can actually put squash and stretch onto that bone and actually squash and stretch it if you wanted to. So if this was a cartoony character, this would be a great solution for getting a bit of squash and stretch. I'm going to leave the freeze length on. That is only actually for interactive stretching. We can override that once we wire this to have it automated. We need to be able to get the value, the length, the starting length between this object here, which is the nub bone for the end of the foot, and the top of the thigh. Now problem is the top of the thigh, this thigh bone, will actually be stretching as well. So we can't include it in the expression or else we'll have a dependency loop. It's going to be dependent on itself to be able to get the values it needs. What we're going to do is we're going to create a helper object in the form of a point, and we're just going to align that up to the top of the thigh. I'll do it in orientation as well, just to make it neat and tidy. And we're going to link it up to the root bone of the leg. Now we actually have something to pull the position from that's right at the thigh without it being in the hierarchy of these bones here. To get this starting value, I'm going to use MaxScript again, just in the MaxScript listener. I'm going to use the distance command to get that value. I'm going to use $sign again to refer to selected objects. The only problem now is if I just highlight just the $sign and go Shift Enter, you'll see that the $sign doesn't represent a given object because we have multiple objects selected. It returns selection, which is an array of objects. To get to the first one in the array, I want to put square brackets with a number 1 in it. That will return the first object in the array. And distance needs a second object passed to it as well. And this will return the second object in the array. And if I evaluate the whole line with Shift Enter, it'll return the starting length or distance between that point object and the ankle. So now we know what the original starting length is going to be. We're going to have to use this in the math to make sure that we don't have a leg stretching before we want it to. I'm going to start with the nub bone at the end of the leg that's going to stretch the calf.